All right. Hi, everyone, and welcome to our ARM AI Tech Talk today. Welcome all around the world for those, whether it's morning, afternoon, evening. It's great to have you here today. We've fantastic. We even got the slides full screen. There we go. Fantastic. Thank you so much all. So yeah, welcome to everyone joining us from around the world, and welcome especially, of course, to those of you watching on YouTube. It's great to have you folks here as well, watching our AI Tech Talks. If you're new to this series, this is all about the latest in AI from ARM, the latest in AI trends, technologies, and best practices from speakers from ARM and speakers from our ecosystem. So if you've got any interest in AI, this is the place to be. We've had a bunch of talks over the last couple of years or so, and this is the latest in them. So it's great to have you here today. And of course, big thank you to all those who are repeat visitors and people who've come before. So let's go on to the next slide, if that's all right. Oh, I think Saul just stopped sharing. All good at your end, Saul? There we go. Just coming back. Fantastic. Thank you so much. So yeah, you can absolutely please get involved in the conversation. There are multiple ways to do this. You can tweet us at ARM Software Dev. Use the hashtag AIVTT to do so. Please also do, as I mentioned, there's a bunch of these talks. These are fantastic education, particularly if you're new to AI, from everything from quantization all the way through to model optimization, everything through to the latest in ARM software releases, hardware releases, and of course, the latest from our ecosystem. So do check out our YouTube channel. That's got all the recordings on there. Everything you want from our AI Tech Talk series is on there. So do check that out. And of course, do please sign up for our next AI Virtual Tech Talk, following the link there, arm.com/tech talks. You can see all of the next few Tech Talks scheduled. If you want to get a sneak peek, let's check a look at our table of upcoming talks. Thank you so much, Saul, on that side. We've actually got a few more talks scheduled than this. We just haven't had a chance to get them live yet, but rest assured, we've got a bunch of talks coming up throughout April, May, well into June and July. So we've got our next talk coming up is from our AI partner, MicroModels. Talk about quantization by heuristic approach of LSTM layers. So that sounds really, really exciting, very technical deep dive there. So if you're interested in that, do sign up. I also then, let's dive into today's talk, shall we? And really excited to have Sama here today and speakers from Sama. They are an AI partner we've been thrilled to have on board for a far time now, and it's been great to have them as an AI ecosystem partner. We wanted to do this talk for a while, and I'm thrilled we've been able to schedule it today. And I'd love to hand the floor over, just before I do, hand the floor over to Saul and the team from Sama, and you get a chance to hear all about data labeling, which is really, really exciting and interesting. If you've got any questions at all, please do use the Zoom Q&A box for those of you joining on Zoom. For those on YouTube, just follow the link I put in the chat and you can ask your questions to our speakers. So just use the Zoom Q&A box down below. Any and all questions are welcome. And that's everything, I think. That's all the housekeeping. So, Saul, great to have you today. Thanks so much for joining us. And the floor is yours. Take it away, sir.
Thanks so much, Tobias. And thank you to ARM for hosting us here today and assembling this great audience. As you said, hi, I'm Saul Miller. I'm Sama's Senior Director of Product Management. I support Sama's product managers specifically around data labeling, where every day we're working to ensure high quality training data efficiently and reliably reaches our customers. So if you've ever thought about how having access to high quality training data would help you solve your next computer vision problem, today's session is for you. By the end of this session, I'm really committed that you'll have a clear understanding of Sama and the role we play in the data annotation and computer vision lifecycle. We'll take a look at the exciting time that it is for training data and the use cases that we're seeing in the AI gold rush. And then specifically today, we're going to take a look at some innovative technology as it relates to ML Assisted Annotation with MicroModels, specifically for instance segmentation type tasks. We won't just talk about it hypothetically, we'll look at it in context of an automotive industry use case and a production example for us. And then probably the most exciting point is that we'll take a look at that technology happening live within Sama's training data platform in a few different scenarios. And then finally, hang on until the end for the conclusion. We'll have lots of time for your questions, as well as we're happy to offer a $150 Raffle for a $150 gift certificate, or to a donation to a charity of your choice at the end for people who participated, and we'll distribute that link at the end. So let's jump in. Let's talk about Sama, first of all, who I have the honor of representing today. Sama is the training data platform trusted by the world's most ambitious organizations to help them develop accurate machine learning models. I'm happy to kind of show the logos here on the screen, some of our trusted clients and partners, some of which have been with us for years. We've been doing this for over a decade at this point. But more so than me and my face and the logos, let's look at a quick promo video that can highlight a little bit more of Sama's capabilities. Perfect. So as hopefully that video helped you appreciate, Sama offers a wide range of capabilities in the training annotation space, particularly in computer vision. As things were jumping around on the screen there, you probably got a chance to see some of our vector annotation products, relates to polygonal annotation, bounding boxes, also offering that in a video object tracking based context. We offer raster, semantic segmentation, raster masks, as well as 3D LiDAR sensor fusion, all housed within our best-in-class data annotation platform with the ML enablement, as we'll look at today, but also the human-in-loop quality control and with API-first capabilities to integrate into your architecture. Sama is very much a global company. So we have our corporate offices in San Francisco, Montreal, and Costa Rica, and the Netherlands. And then in addition to being an innovative tech company, it's also important to appreciate that we are a vertically integrated organization. So we develop our own data annotation capabilities and technology, but we also own and operate our own delivery center facilities where thousands of annotators are working on training data problems every day in Kenya and in Uganda. And as much as we're really proud of our tech stack and being very much a tech-forward company, it's also important to appreciate that Sama was originally founded as a nonprofit organization. Today, we're now operating as a certified B Corp, but playing the role that we play in the ethical AI supply chain is really key. And that social mission impact is why a lot of us show up to work every day in the way that these kind of data annotation tasks allow us to provide dignified work to a broad range of people, and what that allows them to do, actually lifting themselves and their families out of poverty, is a big part of what we do. We did recently release the results of a randomized control trial that we did in partnership with the Poverty for Innovations Lab at MIT that talks about our impact model and dignified work and living wages that we're able to pay our annotators, and how that statistically significantly improved their results over the population. So I'm just going to post that RCT results in the chat there as something that we're really proud of. Well, let's move on to talk about the role of training data in the AI development lifecycle. And the reality is that without training data, there is no AI. And when we look at the process of bringing a high-performing computer vision model to production, we need to acknowledge that the bulk of the work happens before modeling in the value chain. You can kind of see here laid out. You have to collect the raw data, images, video, LiDAR frames, organize all that data into different data sets, identifying and analyzing what subset of that data is going to require annotation. Of course, the labor-intensive steps of enriching that data or labeling it, all of that, about 80% of the effort, all before we can kind of get into I think what people traditionally think about as the elements of the ML development lifecycle with model development and training, tuning, and deployment. And then, of course, there's an important feedback loop once we get out there in the world, seeing the results, identifying perhaps the need for additional data to be collected, certain edge cases to be covered, identifying those in your data set, and doing additional training data and labeling. And when I talk about the AI gold rush, we're really seeing a bunch of industries really waking up to the potential of how a high-performing computer vision model could really help them solve their business problems, delight their customers. I think, in my mind, one of the early adopters in the space was certainly in autonomous transportation, where we're talking about advanced driver safety systems all the way up to full level 4 autonomy, but also driver alertness detection systems. That does also extend outside of just traditional navigation, but also maybe delivery robots. Certainly we see demand and use cases in the e-commerce and retail spaces. I think for a while, ML's been used to make accurate predictions to a customer in terms of other products that they may be interested in, where we're seeing that now evolve into things like a virtual try-on experience. It's a little bit more computer vision heavy. In computer communications, media, entertainment, we're seeing some nice, let's say, innovation in the at-home workout space, particularly in the COVID world these days, that rely on accurately detecting the user's movements in smart hardware, software, and also in biotech, but maybe not just biotech, but also in agritech, for example, using computer vision algorithms to detect pests or diseases, for example, on crops and things like that. So as the computer vision world continues, we're seeing really broad applicability, and all have a strong need for training data as a key input to that model development lifecycle. So now that we kind of have a foundation of the various use cases and applications of these computer vision models and the role that training data plays in them, let's look specifically at ML Assisted Annotation powered by MicroModels. So first, why ML Assisted Annotation? We have to, again, acknowledge that annotating images, particularly in instance segmentation and scene segmentation based tasks, is very time consuming, really valuable, but very time consuming. And there is a role that ML can play here by automating the tasks that can be learned by a machine, but purely machine-based approaches still miss out on the human component to verify and adjust the machine's output. And so there have been existing models out there and methods to speed up the process, like Dexter, which is the approach that we're going to look at today. However, in the academic environment, they're typically not tested in a production at scale and with the high quality requirements that we see from our clients. And it's important to also think about the human and machine interaction in that experience, because the ML output needs to be easily edited by human annotators to bring it up to that quality SLA. So when we say micromodels, we're really talking about an architecture that allows us to expedite the labeling process by drawing on library models trained on specific use cases. These are lightweight models that can be more scalable and robust and brought into production more quickly and significantly greater accuracy. This is in contrast maybe to some of the other approaches in the market with traditionally monolithic models that may store customer data, require retraining an entire model on new data sets and use cases, and not very scalable. On the micromodel side of things, the approach we're taking, there's no storage of customer data. We have a library of models trained on industry-specific use cases, which one makes them more lightweight, easier to retrain and be flexible, and the end result is better accuracy at prediction time, allowing us to be more scalable and robust with this approach. So here's a good visual of what I've been kind of talking around here, right, is an example of object and scene segmentation. The segmentation produces a mask that delineates each object in the context of instance segmentation, which is what we'll look at today, or you can also see semantic segmentation-based approaches where you're semantically by drawing the contours around each category in the scene. And the approach we're going to look at today involves few-click annotation using a Dexter-based approach. So in the Dexter-based approach, the user enters 4 extreme clicks, leftmost, topmost, rightmost, bottommost of the object of interest. We take those user inputs to concatenate the heat map of the image to make an input into the model, pass that input through a segmentation model of your choice, and get a prediction of a raster mask. One step then further in these vector annotation-based approaches is then to take that raster mask prediction and transform it into a sparse polygon that would be returned in the interface for the annotator. You kind of see some visual results here again in kind of an academic-based approach, where you can see the examples of manually drawn polygons and then the end result of the ML predicted polygons with the few click method. It's important to talk about the interactive, the human and machine interactions here. So certainly you can see that the few click method provides a similar IOU, and even more importantly, produces vertices similar to the hand-drawn one. So it's returning a polygon that looks similar as if the human annotator had drawn it themselves as the key handoff point for then that audit and refinement. And our ML team actually presented a research paper on this topic looking at the human-centric efficiency improvements from image annotation. It was presented at CVPR. I'll just take a second to post that link in the chat if you want to read more about this approach. Try that one more time. Just pasting it in the chat. And again, the human and machine interaction point here is really important, as you'll see when we get into the live demo, that both the user providing those fork string clicks helps the model make a more accurate prediction, and the user is engaged in the co-creation of that prediction that they will then refine to the high level of quality that's needed. And so at least in our initial academic and kind of controlled environment testing, what we saw was that the ML models were predictably producing 94 to 98% accuracy in the polygons when they're pre-trained on specific use cases for that better performance at the gate. That has a substantial impact, 2 to 4x more efficient annotation process on those supported classes. And we're able to do this in an integrated way so that after an annotator may make corrections to the model prediction, that's fed back into the model for additional training. And because they're lightweight, we can retrain and be quite agile in that constantly improving models. And that clients can then use this high quality training data to bring their models to production faster, producing higher volumes of that high quality data faster. But looking at it in kind of a controlled A/B testing environment is one thing. Actually deploying it in the wild on an end client use case is another. And so I wanted to take that to just the next degree of clarity when we talk about an automotive case study, one of our production engagements. So in this case study, we were working with a tier one, kind of anonymous tier one automotive supplier, and of course delivering high quality annotation to that in a instance segmentation based use case. It was a highly complex workflow involving various camera data sets, different weather and seasonal conditions, and as always with a client engagement, a massive data set, tight deadline. And so in our approach, we implemented these ML Assisted Annotation to reduce the time spent on polygon drawing and increase annotation efficiency. And important to talk about that in an integrated pipeline approach because of the various weather and seasonal conditions and the varying data set require two things. One, we benefit from the human input to establish those 4 extreme clicks in terms of the object of interest, even with those various scene types, and that the MicroModel approach can be retrained quickly and deployed quickly to keep up with those changing scenarios where maybe a monolithic model may have struggled with more model drift in those scenarios. And what we were able to see is that we had a 27% decrease in overall project length. The model in production performed at 96% IOU, so really high performance, particularly considering the dynamic data set. I'm quite pleased with those results. Okay, so now we'll kind of hop off the slides and have a chance to take a look at this in action. I'll try to cover three major themes. One is using MAA to do initial polygon drawing, adding additional clicks to do polygon editing as well. And then I'm really excited to be able to share with you today also something that we're doing in a prototype right now, which is actually moving the ML predictions out of the server side and actually bringing it into the browser. So look forward to sharing a quick prototype there as well. So let me hop out of the screen share and move over to the Sama platform for the live demo. So okay, welcome to Sama app, our integrated platform. I'm here in the annotation workspace with an example of a scene segmentation or an instance segmentation task. You can see, let's say that we need to annotate individual instances of our vehicles and of our bicycle riders here. And certainly, and let me just zoom in to make a high level. Let me zoom way in here. And in traditional methods, right, we would annotate this manually with a tight fitting polygon. So I'm just clicking around here. I won't ever pretend to be the high quality annotator that our teams do every day. So I'm just clicking around here to create a tight contour all the way around this object. And let's call that good enough for me doing the demo today. Okay, so that's how it can look like in a manual-based approach. Let's now look at it with the machine-assisted annotation approach. So let me just change modes here to switch now. I just use the keyboard shortcut, but I'm switching into the MAA polygon mode, where I now have a crosshair cursor, so I can very quickly identify the extreme left, the top, the bottom right, and the bottom most of those. Those are the 4 extreme clicks that are then passed to the micromodel, and voila, returning a prediction for a tight fitting polygon for that instance. You can see here following the detailed contours, and again, kind of representing the subpoints as if a human was drawing them. I can see that there is a little bit of tightness needed here. So let me just do a little bit of cleanup here and maybe even add 1 or 2 more points here along the wheels to just make it that last tight. So minimal intervention needed from the annotator. Let me do that one more time, maybe in an example of the bicycle use case, even more fine-grained detail. And again, if I were to try to manually annotate this, probably on the order of magnitude of, I don't know, 40 to 50, maybe even more vertices to get that finely grained contour. Or, again, in the MAA-based approach here, 4 extreme clicks to produce that tightly fitting contour. So some really exciting stuff as it relates to the ability to produce high quality annotations efficiently and effectively in this integrated experience with the agent annotators. So let me move a little bit over here, and I'll just do one more in this context. And again, come kind of super in here, and I'm going to kind of intentionally make a mistake and see if I can show you the ML assisted. So I kind of intentionally cropped out the mirror there, and let's see if the other thing that we offer is ML assisted editing. So let me see if I can do this. I'm now adding a 5th point into that model. There you go. And you can see it kind of recognized now a 5th point coming in re-predicted and was able to capture the mirror. So that's what's really powerful here, is it's not just about the initial prediction, but actually the ability to add a 5th or 6th or even 7th point to really get the level of detail that you may need. And then kind of some minimal cleanup might be needed here across the board. So that is what machine-assisted annotation for an instance segmentation task looks like. What you maybe wasn't clear behind the scenes here is those 4 or 5 extreme clicks, then creating the crop of the image, getting passed to our ML MicroModels on the server side, and then returning the polygon in the workspace for additional refinement and cleanup. So now let me jump over to a prototype environment. So in this prototype environment, let me just reset it. There we go. In this prototype environment, we're taking it one step further. So in addition to those server-side calls, I'm actually hosting the model. It's not quite the same model we were just using over there, but hosting a model here locally on the user's machine. And what we're hoping for in this prototype is actually to decrease the latency and the response time between the model transaction and the response. What we see in production with the production feature is maybe 2 seconds max in terms of response time, and we're able to shave that off or cut it about in half with the ML in the browser-based approach. So here in this prototype, you can see again that mask getting created, but in this scenario, a little hard to tell behind the scenes, all happening within the browser on the workstation itself. No server-side call to produce these results. And what we're really excited about with this capability, even though it's just a prototype, is that as we continue to drive the response time between the user input and the model response down, particularly combined with our micromodel based approach, is that opens the door to a few more interactions, right? If we are cutting down the response time for those model predictions, then maybe actually we're able to present the user with a model prediction preview before, right? Or maybe even multiple model version prediction. We could show them 3 or 4 different model predictions, and they can actually choose the one that's the best fit. So having the ML in the browser and here on the edge, plus the micro-model based approach, where maybe there are multiple models competing for the most accurate result, opens the door to some really interesting innovations that we're excited with this prototype and happy to share it with you as an early indicator of some of the direction that we are exploring in this space. So hopefully you found that demo as exciting as I did, both the polygon drawing, the editing, and the prototype. Let me just jump through here. And we'll move on to your questions in just one second, but I did want to certainly thank you for joining, and thank you, Arm, for having us, with a reminder that there is an opportunity to enter a raffle following up to win a $150 gift card or to a charity of your choice. So I'll just in case people want to drop off as the questions and engagement happen, I'll post the link to that raffle. Oh, thank you. Guillaume is supporting me here to just call attention to that survey link to enter the raffle. And with that, I will come back and I'll kind of drop screen share because I'm not sure what the questions are going to be, and I'll go back into the deck or into the platform itself, depending on what the questions are, whatever the visuals may be.
Amazing. Thank you so much, Saul. That was just an awesome demo. I love a good demo, and that was just great. It's the kind of thing that I feel like I could go and really use. And I think there's a lot of, I'm sure the people on the call, clamoring to find out more and get involved with yourselves and help out where they can, and improve their project time as well. So I mean, just as a very quick one, what would be the best route to get in touch with yourself? I know you flagged up a couple of things at the end, but have you got what contact details, website, etc.? If you want to talk about those, it'd be good. I'm sure people want to get in touch with you. So do you want to talk a bit more about that?
Yeah, absolutely. So I think that there's kind of 2 paths here. One, of course, if you want to get in touch with Sama, certainly sama.com is the best way to learn more about our capabilities and get in contact with our external facing teams. In terms of me personally, I'm happy to also share my LinkedIn details. I'll put them in the chat so you can get a direct link to me, and that's typically the best way to reach out. I always look forward to engaging with people in this space who are equally passionate about data annotation and computer vision and all the innovations that are happening in this space. And I'm happy to post the link to my LinkedIn in the chat as well. And I would love to keep in touch with this group.
So do reach out, folks. Do reach out, and do check out their website as well. And as you said, it's such a key part of this overall kind of talking about the latest in AI trends, technologies, best practices, and talking about anything AI. We it's great to hear about this. It's something that me personally, I know Arm are really keen to hear about. One thing actually I did want to clarify, and folks, do get your questions in, please, on the Zoom Q&A chat below. All and any questions are welcome. We could even potentially unmute people if they've got a question they want to ask. You mentioned about, and for those who may be new to AI and looking at this, I think you mentioned the phrase IOU, I think it was intersection over union. Do you mind yourself or Guillaume or whoever just explaining what that is and just explain a bit more about that? Because I think that was the only term in that people might have questions on. But by all means, if anyone else has got any questions about anything else, please do flag that. So yeah, IOU. Could you tell us more about that, intersection over union?
Yeah, absolutely. Let me see if I can do it here in the interface. Sometimes a visual can also be really helpful. So the concept of intersection over union is a quantifiable measurement for how to compare two different shapes. And so in this context, the two different shapes that we want to be comparing is actually the initial polygon that the model predicted, and then the final polygon after the user may have made some modifications. So you kind of have the model prediction as one shape, or one version, let's say, of that shape, with the final result after any human modifications. And if you have those two shapes, then you can look at their intersection, which is essentially the area. Let me even draw a second polygon on here. I'm going to make it a little bit rougher just so it is okay. So now we have a second polygon on here. Let's say that this was the initial model prediction, then we know that it wasn't, and that after edits, this was the final result. And so the area, and actually, let me make it a little bit stronger. I'm going to not have them perfectly overlap because that's important for the calculation as well. So what we would then, by looking at these two shapes, we would consider their intersection to be this Venn diagram, this area here that overlaps between the two shapes, and their union would be the full area covered by the outside contours of both of them, right? And so those are that then just becomes your numerator and your denominator. So you're taking a look at the share where they perfectly overlap, where there's agreement, relative to the total area covered by their union. And so that ratio, when they match 100%, when the intersection is 100% identical to the union, that's where you have a really high IOU score. It says, hey, they're actually identical. But as they start differing more and more, then that IOU starts going down. So basically it's a quantifiable measure to say, hey, what's the level of agreement between these two shapes? And we use that as a key metric when identifying how our model is performing relative to the prediction and after the human annotator would make any corrections. Great question.
No worry, no, great answer and really, really interesting stuff. So I hope folks on the call found that interesting as well. We've got a lot of people on here. The audience are, I'm sure a number of them very keen on developers. So, do you have any insight or examples of how they can, how can they use this on their ARM devices? How can they take this? How can they get involved and work with yourselves to, any examples you've got of working with ARM-based devices? Because I'm sure there'll be the people on the call will be really interested in that. So any tips, any advice, any past experience you want to share?
Yeah, absolutely. So I think that kind of there's two ways to approach this, having to do with Sama's kind of two different business lines, and it really we see it differing a lot depending on where folks are in their ML development lifecycle and where they are in their maturity. So the first is, if you would go to our website, you could see that we have an alpha product right now for folks to actually self-sign up and get their hands on the annotation interface itself directly. And so that's really good if you're kind of earlier on in your development lifecycle, still experimenting with different annotation techniques and types, and want to just kind of get hands-on with you yourself, putting yourself in or someone on your team being in that annotator seat in terms of annotating on screen and producing these annotations. And then you kind of have Sama's enterprise offering, which is where we're providing the training data as a service, where we have a managed service product where we really do this at scale, right? And it's actually working with our managed service kind of full-time annotators, I mentioned, based in East Africa, to produce these high-quality annotations at scale and really feed that into your computer vision model that would be on that ARM device, particularly within these instance segmentation use cases. We're focusing on them for twofold. One, because for anyone who's tried to produce high volumes of instance segmentation data, they know it is quite labor intensive to get that high level of contour and refinement, and therefore also the biggest opportunity space for machine assisted annotation to increase that efficiency while still retaining that high level quality that you would need in your model at prediction time in production, knowing that your training data had this level of quality and increasing the volume as well.
Brilliant. Thank you so much on that. And yeah, just separately, I've just seen in the chat, make sure you enter the raffle on the link that we posted, that has been posted in the chat. And also I've just seen a question from David. Thank you on that. In terms of recording, yep, recording will go live straight after this. It will be edited just to remove the fancy intro we've got and all that jazz. But it will be live literally straight after this. So if you've missed any part of it, if you've joined halfway through and you've missed any bit of it, you've seen the great demo and thought, wow, let's go back a bit. You can absolutely do that. Check it out on YouTube. The ARM Software Developers YouTube channel is the place to be. And of course, do subscribe to that as well. In terms of other questions, I had a couple of other questions as well, but audience, please do ask any others you've got. How is you mentioned about the machine assisted annotation that you've got. How's that different from pre-annotation?
Yeah, absolutely. So it's a great question, and I think that in the space, right, any opportunities for putting automation into the annotation process is worth exploring. Again, the target there is that high volume of high quality. And so when it is very labor intensive to produce that, any opportunities for automation in that process will be welcome. In traditional pre-annotation techniques, and there are definitely instance segmentation based models out there, what that would look like is kind of when the annotator would have first come to this workspace, there would have already been polygons here. Again, imagine me returning to this is kind of simulating that experience, even though I drew these in an interactive way. And so that differs in two main ways. One, a pure pre-annotation technique relies on the ML model to, first of all, identify the objects of interest and then produce the segmentation masks as a second step. And so that definitely makes the ML problem significantly harder because you have to do both of those things. And the second thing that we found and observed in our experience, and what I put in the chat in terms of the research paper that we published, is also the human and machine interaction is really important to this experience. So by actually engaging the human in the co-creation of that polygon, we get to do two things. One, with those kind of limited human inputs, with those 4 extreme clicks, first of all, they're providing a really valuable piece of information to the model, right? They're saying, hey, it's not just this object, it's this object that I'm interested in, and here are its approximate boundaries. So kind of limited human input, they're adding a lot of value that can help improve the prediction itself in a way that you don't have that benefit of pre-annotation. And again, to me, almost more importantly, because we work with our annotators every day, is then they're co-creators in that process, right? They're getting that model, they're getting that prediction back, but they're not just passive. It's not just, hey, I'm auditing this polygon that was drawn by a robot, right? This is science fiction stuff, right? But actually that they were co-creators, and then there's actually a sense of ownership and pride and accountability in that polygon when they then get that handoff from the robot, so to speak, right? To actually make the really detailed refinements that a human can do using human judgment and best case. So those are some of the biggest differences that we see between a purely pre-annotation based approach versus a more interactive annotation based approach.
And kind of following on from that, and I'm sure, as you covered a bit of this already, but is there anything else you'd like to add in terms of how can you ensure really high quality annotations with this, with the introduction of machine learning? What's the kind of tips around that you want to have?
Yeah, so I mean, again, to us, what we see is that the human intelligence is really the key, right? The ML can take it so far to that 94, 95, 96%, but for some of those higher quality annotation requirements, depending on the nature of the task, and particularly if you are using this as your ground truth data for both model training and for validation, the high quality annotation is really key. That you'll want to make sure that the pre-annotation or any model prediction is happening in an integrated annotation experience. So that's the first step. The annotator is essentially now becoming that first level and giving them the access. I was kind of showing some of those advanced tools here, like this one. If I wanted to just dynamically extend this polygon, that editing is really important, or to be able to kind of bulk delete and clean up. So you want to have a robust interactive experience for actually creating those additional, doing that edit experience. So that is number one. I think the other key piece here is the larger capabilities in terms of quality management on the platform. So in the case of the Sama app, the human annotation interface is only one step. We also have auto QA that sits on top of this that can detect more programmatic and logical errors. And then this is part of an integrated workflow where there's a lot of flexibility depending on your annotation type and your quality requirements, whether it's the same annotation maybe goes through multiple reviewers where another person could also look at it. Or we also use a lot of statistical based sampling approaches where maybe a subset of the work is really inspected with another set of eyes, and we're identifying more statistical trends as it relates to quality that could inform where additional rework or cleanup is needed in that data set. So I think that all of those would contribute to best practices in terms of the end deliverable that would flow over our APIs back to our clients.
Amazing, thank you. And finally, on my side, how are you guys different from other data annotation providers? What makes you guys stand out?
Yeah, so I mean, I think that from our perspective, a lot of that happens as it relates to our kind of our structure, both as a B Corp, but also as a vertically integrated company. So, what I observe in the market is there's typically some players who are really focused on the annotation capabilities and the technology, and maybe their core model is kind of licensing that annotation platform to others to actually do the annotation themselves, whether that's directly their clients or their clients are then subcontracting out through maybe a BPO or a crowdsourcer. And then that's exactly that. You have that on the other side of the spectrum. You have folks who kind of specialize in the scalable human workforce world, right? Maybe they're doing data annotation, but they might also be doing call center or data entry or data transcription, but they really specialize in employing large amounts of people. Or even in that outside of the BPO world, there's also kind of crowdsourcing models where people are just picking up individual tasks, in a more crowdsource based model. And so where I see Sama both as an impact organization, but also as a vertically integrated, we kind of sit in the middle of those two spectrums where we are developing our own annotation capabilities, but we're also directly employing full-time staff, kind of expert annotators out of our secure ISO facilities in East Africa. And so that gives us kind of total control and total visibility on the entire data annotation process, from kind of the initial task creation or asset handoff from our customers all the way through to the ML model development, the interface. Those are our kind of in-house people who are using that interface every day. And so giving us a lot of feedback, allowing us to really get this right. All the way to the quality management process and the end deliverable going out. So kind of like all that happens within our walls, and is something that I think makes us both really different in terms of our ability to be flexible and agile and the end quality deliverable, but also for us to stay true to our social impact model and dignified work, so we control every element of that process.
No, absolutely. And I think one of the things that really struck a chord with me personally, I'm sure many in the audience, was around your mention of and focus on ethical AI on this, and it's great to see that as well. On Sama's side, it's such a key part of this, and it's great to see, as you mentioned, on that side of things. So, with that, has anyone else got any final questions for Saul and the team? This is your last chance to get your questions in. As I mentioned, all the slides and recordings will go up. The slides will be up in a couple of days. Recording will be up the end of literally straight after this. Has anyone got any final questions for Saul and the team about anything to do with Sama, data labeling, data annotation? This is your time to ask. And of course, do enter the raffle. Sorry, Guillaume's just posted the link again in the chat. Do please enter the raffle. You've got an opportunity to win $150 gift card or donate to charity. So that's an awesome opportunity. So do enter that. It doesn't take that long, and it'll be a great opportunity for yourselves. With that, I think, Saul, do you have anything final to add on your side before we wrap up?
No, just a thank you again to ARM for hosting me here today and assembling this great audience. Is really exciting to be able to share Sama's approach to machine-assisted annotation with you, even some prototypes. Look forward to bringing those to production soon, and please do keep in touch.
Thank you so much. Thank you so much. Thank you, everyone. And it's an absolute pleasure to have you guys presenting today and giving a fantastic talk to our audience. So thank you to yourselves. Thank you to the whole Sama team for a fantastic presentation and preparing great content. We'll get that all up by the end of the week, and that'll be awesome. Oh, we do have one question that's just come in, just at the last minute, just before I wrapped up. So, how do you initiate a data labeling project from scratch? This is a question that's just come in from. Apologies if I mispronounced the name, Subham or Subham. Saul, do you want to answer that?
Great. Yeah. So, I mean, I do think that when we think about that. I'm not quite sure exactly where you might be in the life cycle, so I'll kind of answer holistically, maybe for the broader audience, in terms of where from scratch could really mean. So certainly, clearly framing the problem area, I think is the first step in the opportunity space. Then identifying that data set and data collection step of what you'll really need to address that, particularly in terms of the varying degrees of scenarios you might expect to see in production. Really identifying the subset that's going to be worth doing the labeling, as well as identifying any off-the-shelf models or any in-house model expertise that you would want. And there are a bunch of now open source and kind of ML as a service products out there, even from some of the biggest players. I really do see ML getting increasingly more democratized, for sure, both in terms of the more available tools and platforms that are out there, but also in my mind, one of the exciting things about machine assisted annotation as it can decrease the barriers to entry to high volumes of high quality annotation. It's not just for the big players who might have millions and millions of dollars in data annotation budgets, but actually that even the smaller startups and people in the space can start getting access, and not just relying on kind of open data sets and things that have already been annotated, but something that's actually custom annotated for their use case. And then that's also why our kind of Sama Go Alpha product is so powerful. If you're earlier on in the stages, kind of getting up to get hands-on with the data annotation platform yourself is actually a great place to start. To load some images, get your taxonomy all set up, annotate a few of them, maybe with a few different approaches. Maybe you want to experiment with bounding box-based approach or a vector polygon-based approach, and kind of iterate yourself and kind of internally there within a smaller team. And those are some of the key feedback loops that then would really set you up to say, okay, I have some initial prototyping, maybe a toy data set that I'm excited about, and I want to actually kind of boost now and say, hey, I want to produce a high volume of training data, and that's where Sama can be a key partner, and in a way you may not want to scale with your small team, or certainly, we hear lots of stories of very highly educated, very highly paid ML engineers who are spending hours doing the data annotation work, and that's where we can really take that burden off of you, and both in the annotation process, but also the quality management process, to let you focus on the model development and training.
Amazing, great answer. Thank you so much, and I hope that answers your question. I think we just had. Do you also provide data collection services? From someone who's just had a follow up.
It is something that we don't offer today, but that we're exploring pretty seriously, and we certainly actually already today have kind of a network of partners in the ecosystem. So if you're engaging with us in that conversation, at the minimum, we're able to kind of help you solve that need through our network, if not directly in the near future.
Amazing, thank you. That's great, and yeah, no problem, Evan. Thank you for your great question. Unless there's any final chance for your questions to come in, as I say, we'll probably wrap up, and thank you again so much for a great presentation, and for you guys coming today, and to our audience, thank you for your great questions and great attendance, and we look forward to seeing you in a couple of weeks time. As I say, we've got Imagine Mob talking about quantization, and actually straight after that we should have a really interesting topic from ARM ML research as well, which should be going live by the end of the week. So on behalf of myself, the ARM team, and of course Sol and the Sama team, thank you all so much for watching, and we'll see you again